Hello everyone, welcome to my channel EC on Tips. In today's lecture, I will be teaching MOSFET. So, MOSFET, it is a metal oxide semiconductor field effect transistor. It is mainly of two types, that is enhancement type and depletion type. Now, enhancement type is a MOSFET in which the channel does not exist physically, that is, it is created. Okay, and depletion type is the channel exists physically. And now enhancement type is further divided into N-type channel and the P-type channel. And similarly, the depletion type is also divided into two types, that is N-type channel and P-type channel. Now let's study more about MOSFET from its structure. Now you can see that MOSFET, it consists of a P-type material substrate, that is body. Now on this body, two N-wells are formed by diffusing the N-type material on it. Now due to this N-type material and P-type material, there will be a formation of a PN junction. Okay. Now this region is called as a depletion region. Okay. Now at the bottom of the substrate, a metal contact is attached. This is a metal contact through which a terminal can be attached. Now the same metal contact is attached above these N-wells, like this and like this. So these are the metal contact attached. Now between the source and the drain terminal, there is a thin layer of silicon dioxide attached to it. So this is SiO2. So what it is? It is silicon dioxide. It acts as an insulator. Now in terms of capacitor, if we talk about, it acts as a dielectric material. Okay. Now above it, there is again a metal contact attached. Is it clear? Now what we do is we connect the source terminal and the body terminal with to a ground. Okay. Now both body terminal as well as source terminal are connected and they are grounded. Okay. Now as we all know that MOSFET is a three-terminal device. That is, it consists of a source, drain and the gate terminal. As the source and the body terminal are connected together, so it will consider as a single terminal. So this is 1, this is 2 and this is 3. So it is a three-terminal device. Clear? Now the question arises, will there be a flow of current? Will this circuit work? The answer is no. There will be no flow of current and the circuit will not work. Why is it so? Because of this PN junction formed. Because of this depletion region, there will be no flow of current. In general, in MOSFET, there will be flow of current from drain to source. But here, in this structure, there will be no flow of current. Now, what we can do is, we can attach a terminal between the source and gate. So this is gate terminal, this is source terminal, this is gate terminal and this is drain terminal and this is body terminal. Clear? Eh? Now the source terminal and gate terminals are attached to the potential of VGS. And similarly, we attach a potential between the drain and the source. Now if we increase the potential across this VD Yes, if we increase this VDS value, then what will happen? There will be a flow of current. By increasing this VDS value, there should be a flow of current. But what is the problem? As the drain is at the higher potential, the source is at the low potential, there should be a flow of current from drain to source, as this is at high potential. But what we observe that this is N-type material, this is P-type material. So when the current flows from N-type material to the P-type material, it will be in a reverse bias, isn't it? So there will be depletion region will increase. Okay. So there will be no flow of current. Now the question arises, how we can do? So we can do it by forming a channel here. Now how we can form a channel? The channel can be formed by attaching a battery across the source and the drain. Okay. So this is at the positive and this is at the negative. Now what will you observe that if we attach this positive terminal here, this is negative. So this positive charge will appear here at the gate terminal, and due to which what will happen? All the electrons from the P-type material will accumulate over here. Okay. The electrons will accumulate over here. Now, but this is positives, this is electron, but these electrons will not be able to pass to the gate terminal, because this silicon will act as an insulator. This silicon dioxide will act as a insulator. It will not allow the free electrons to pass through it. Okay. Now, what we can do is by increasing this strength, by increasing this VGS value, we can increase the concentration of electron over here. So what will happen? The electrons from this is silicon structure. So electron from this silicon structure will just come out and create a hole here. Okay. So this electron will move towards this concentration and this hole will come here. Okay. The hole concentration will increase here and the electron concentration will increase here. So what will we observe is that there will be a formation of a N-well. So there will be a formation of N-well. So this structure, this region will act as a N-type material because the concentration of electron is higher over here. Now, if we keep on increasing this VGS value, the electric field will keep on increasing and the electron will accumulate over here. Okay. And that will form a channel. So now our channel is formed. This is source, this is channel, and this is drain. Got it? Now, this channel is created at certain potential, that is at certain value of VGS. So that certain potential, that certain voltage is called as a threshold voltage. Okay, that is VT. When we apply this VT, that is threshold voltage, when we apply this threshold voltage, then only there will be a formation of channel. Is it clear? Now, there will be how to increase this current flow. Now, we have discussed that there will be channel which we have formed. Now, there will be a flow of current. Clear? So, now if we want to increase the frequency of the flow of current, that we want that there will be a large flow of current. To increase that, how we can do that? By increasing the value of this VDS. By increasing the value of VDS, we can increase the flow of current. But by increasing this VDS, what will happen? ID will flow from drain to source. But due to increase in this potential, the channel will keep on thinning. This channel will keep on decreasing at this potential because this is at the higher potential. Okay. Now what will happen is, due to this thinning of the channel, that will resist the flow of current, and a point will come when the current will get saturated. That is, there will be no flow of further current. Okay, and that situation is called as a pinch off situation. That is, the channel will be like only this much. It will be left this much. As there is no contact over here, there will be no flow of current. Clear? So this value of VDS is called as a VD sat. That is saturation voltage. Got it? Now the question arises, now as it is in the saturation mode, how there will be further flow of current? Now to further increase the flow of current, we have to increase the channel. And now again, how to increase the channel? By increasing the value of this VGS. If we increase the value of VGS, more concentration of the positive charge, so more electron will attract to it, more electron will move towards there, and hence it will make the channel more thicker, and hence there will be a flow of current properly. So this is the proper function or the structure of MOSFET. So as its definition says, what is a MOSFET? It is a metal oxide semiconductor field effect transistor. That is, it mainly controls the conductivity. That is, how much electricity can flow, how much electricity can flow between the source and drain. Drain terminal is based on amount of the voltage applied to it. Applied to its gate terminal. That is, how much electricity can flow between the source and drain terminal is based on the amount of voltage we applied at the gate terminal, that is VGS. By increasing the value of VGS, the channel will increase, and hence there will be more flow of current from drain to source. So this is the structure of MOSFET, that is N-channel enhancement type MOSFET. Now let's study its definitions. That is source. Source is the terminal through which majority charge carrier enter into semiconductor bar. Okay, here the majority charge carrier enter into the semiconductor bar, and drain is a terminal through which the majority carrier charge leaves the semiconductor bar. Okay. Now the channel. What is channel? Channel is a path between the source and the drain through which the majority charge carrier travels from source to drain. What are the majority charge? Here the majority charge are holes. So holes are moving from source to drain, and the electrons are moving from drain to source. Okay. The gate. Now what is gate? Gate is a terminal to control the flow of carrier from source to drain. From source to drain, to control the flow of carrier, there is a gate terminal attached. Because by applying this potential, that will form a channel, and hence there will be flow of current, and hence this MOSFET will work. So this is all from my side. Now in the next lecture, I will be teaching the depletion type MOSFET. Thank you.